Hello, my name is Justin, and this is my YouTube channel, American Pie. Today we're going to do Leetcode number 111, minimum depth of a binary tree. Given a binary tree, find its minimum depth. The minimum depth is the number of nodes along the shortest path from the root node down to the nearest leaf node. Note, a leaf node is a node with no children. For example, with this binary tree, it starts at 3, the left node is 9, the right node is 20, and the right node continues down to 2 more nodes. Because 3 to 9 is the shortest branch of this tree, 3 to 9 is going to be where we calculate the depth. So 3 is the first node, 9 is the second node. That makes a depth of 2. If we look at some of the other test cases, we can see that some of them don't even have any left nodes. Like this one just only goes right and it goes down to 6. So if we count the depth, that's 5 because it starts at 2. So my usual approach to solving questions like this is to use recursion to traverse the binary tree. And when we do something like that, we need to start with whatever the exit condition is. Now, the way that I want to approach this problem is by assigning each connecting node a value of 1 or 0. If the node does not connect to anything, well, it's assigned a value of 0, so that's our first exit condition. But if we know the node is connecting to another node, we're going to have to increment the depth by 1 and assign a value of +1. I think I'm getting a little bit ahead of myself though, because the first thing we really need to do is just traverse the left and right side of this tree. So to do that, I'm just going to do 2 recursive calls and assign them both to an integer. Next, if the left side returns a value of 0, we know that we can't go down that, so we're going to go to the right side and add 1 to it. But if the right side returns a value of 0, we're going to go to the left side and add 1 to it. Given that one of the 2 sides is going to return 0, this return value will essentially always go with the other side. So we have addressed the edge case that you see below, where we just have one side all going down with this if statement, because it's just going to take the right path and add 1 every single time. But what happens if we have a binary tree that goes both left and right? How do we find the minimum depth? Well, we can use the built-in Java function math.min, and then we're just going to take the minimum of either the left or right one, whichever one is smaller, and we're going to increment by 1. This way it will return whatever the minimum number of connections is. So we're passing all the edge cases, so let's go ahead and submit this. It beats 64%.